Hello. In this video we're going to be talking about the imaginary unit. In the imaginary unit we use the letter I and we set it equal to the square root of -1. Now I want you to think about what two numbers could multiply together to make -1. We know 1 times 1 is 1. We know -1 times -1 is also 1. So there's no number that multiplies by itself to get the square root of -1, and that's why this number is imaginary. So we define I to the first as the square root of -1, and it can be represented just by I. If we do I to the 0, well, anything to the 0 power is 1. How about I squared? If we do I squared, that's the same as taking I times I, or the square root of -1 times the square root of -1, or rather the square root of -1 squared. And we know that square roots and squares cancel each other out, and we just get -1. How about I to the third? In I to the third, we have I times I times I, or maybe I'll look at it as I times I squared, which would be I times, and we just determined I squared was -1. So I times -1 leads us to a -I. How about I to the fourth? I to the fourth, that can be just, well, why don't we divide it up right away? I squared times I squared, or -1 times -1, which is 1. And onward. So I to the fifth is I times I to the fourth, or it's I times, and I to the fourth was 1, so just I. And we're just using everything that we've just derived to get to the next term, I to the sixth. That is I to the fifth times I, and I to the fifth was I times I, or rather it's the same as I squared, which was -1. I to the seventh can be looked at as I to the, I to the sixth times I to the sixth was -1 times I, so it's a -1. So this ends up being the same as I to the third, and then I to the eighth is I to the seventh times I, or I to the seventh is -I times I, so we have a -I squared, which means we have a -1, which is 1, and so I to the eighth is the same as I to the fourth, which is the same as I to the 0. And so the big thing to talk about here is we know that I has been defined as the square root of -1, and the pattern of I is cyclical, every time we multiply 4 i's together. On this slide, we're being asked to simplify these two expressions. So we're simplifying the square root of -36 to start. Now, I know that the square root of 36 is 6. But the square root of -36 is not, because 6 times 6 makes positive 36, -6 times -6 makes positive 36. Nothing multiplies by itself to make -36 until now. So I can break this down. The square root of -36 is the same as the square root of 36 times the square root of -1. If I were to take 36 times -1, I'm right back to the -36. And we simplify from here. Square root of 36, we already said, was 6. Square root of -1, well, we labeled that as I. And so the square root of -36 is an imaginary number, 6i. How about the number 2, where we're doing the square root of -18? In the square root of -18, I look at 18, that's not a perfect square, but I can break it down. 18 becomes 2 and 9. 9 becomes 3 and 3. So there's my pair. 9 is a perfect square. So I can make this the square root of 9 times the square root of 2 times the square root of negative 1. So I've broken into 3 separate square roots here. 9 times 2 times negative 1 gets me back to that negative 18. Well, square root of 9 is 3. Square root of negative 1 is I, still times square root of 2. And there we are. And so that's how we use imaginary numbers. We will talk more about them in class. For now, we are done.